Hey kids, welcome to lesson 11 in module 3 for 5th grade Eureka Math. And in today's lesson, prepare to have your minds blown because we have so many different ways to subtract. It may actually throw you off a little bit, or you might say, OMG, this is fantastic. I've been waiting for this my whole life. So let's hope it's the latter. The objective for today is to subtract fractions, making like units numerically. What's new? Nothing, really. It's just the same thing we've been doing. But we're going to look at a couple different methods. So just as a reminder, the whole is the thing that comes first. You cannot move the whole from any place from here to any other place in your expression or in your number sentence. The whole must come first because we're taking away part from it. Again, fancy words, the minuend is another word for the whole, the subtrahend is what you're pulling away, and the difference is the answer. I won't really use these words. I'm going to say the whole or a part, and I will always use the difference. But I don't use these very often. If you need something to help you remember them, minuend starts with an M, which comes in the alphabet before S for subtrahend. Hopefully that can help you. Now, we still have to get common denominators. This isn't really super helpful. If you want to write that down, great. Pause the video. We're still having to do common denominators when you do your subtraction. If you look at the 3 and the 5, the opposite number is going to be your scale factor. Here's the scale factor. Work out your equivalents, do the subtraction. Okay, this is what you absolutely must write down. Okay, we have a couple different methods. So the first method, follow me carefully. Let's take our 1 3/4 minus 3/5. So 1 can be rewritten as 5/5 because any 1 can be written as a fraction as long as it has the same number on top or numerator as it does on the bottom, the denominator. So if I just change this to 5/5, knowing that I can take away 3/5 from it, that will work. So 5/5, just you get to make it up. Kids are like, what do you mean I get to make it up? Well, you get to design your own fraction for 1 that helps you to work with the subtrahend. So if I have 5/5 minus 3/5, I have now taken away everything, the subtrahend, that needed to be removed. So 5/5 minus 3/5 is 2/5. There's my answer. Now, what about this 3/4? The whole time it's just kind of sitting there getting ignored. So notice the arrow. I'm bringing it down and I'm putting it back with the 2/5. And at this point, you would have to get the common denominator, add your numerators, and you get your answer. Now, it seems kind of like a lot of work. It can work really well with this method. Sometimes if you have like larger numbers and you want to just split it apart and take this away only from the 1. Now, if you don't like that or it's too confusing, you're like, I'm not really sure. Here's another method, okay? Seems a lot shorter, so let's take a look. Method 2, 1 3/4 minus 3/5. Same problem, but looking at the fractions only. If in the beginning you really understand the size of fractions and you say 3/4 is more than 3/5, and I can take 3/5 away from 3/4 by making equivalent fractions, then you can make your fractions right away and only work with the fractions. Okay, and just bring the 1 down, basically ignore it, just keep bringing it down, and then you've got 15/20 minus 12/20, and you get your 3/20. So you've got 1 3/20 either way. Okay, so this is, some people are like, I'm going to do it all that way. Well, you know, it might not always be as easy because that only works because this fraction is big enough to pull from when we're taking away this one. Now, this last method is something that I used my whole life. Your parents will probably be really familiar with it. It's taking that first mixed number and turning it into an improper fraction. So how do you do that? So always a mixed number is just made up of a whole bunch of fourths. Whatever the denominator is, this one happens to be all fourths. How many fourths make up the whole number? 4/4. So it's 4/4, and then it's 3 more fourths. So that makes a total of 7/4. How can you get that regardless of number? Take the bottom number, multiply it by this, add this. 4 times 1 is 4 plus 3 is 7. it'll work that way every time. If you multiply here and then add that, you get this. Or just take that denominator and put that into a fraction and then add those numerators together. Either way, however you can think about it. So when you put it all together, you end up with 7/4. We're taking away 3/5. We already had a fraction. Don't mess around with that in the first step. Just change this. Now we have 4ths and 5ths. Must have a common denominator. Make the common denominators so that you can do the subtraction. But here's where it's going to get a little bit hairy, is that sometimes your numerators are going to get quite large, and it will be kind of a hassle to do this big subtraction. So you end up with 35/20 minus 12/20, which is a little bit bigger than everything we had over here. But you can do it. Maybe you're super good at subtraction. You're like, I like that way. And a lot of my students have said, I like doing it this way because I might forget about one of the parts if I'm taking things apart. And that's a valid concern. Okay, so you end up with 35 minus 12 for 23. Then you have to straighten out the improper fraction for 1 3/20. Now I know this is a lot of notes, but I have a little bit more. Couple more sample problems. So focus. Oh, thank you. 3 3/5. Here's another one. Minus 2.5. Again, think about the size of the fraction so that you can determine if it's big enough to take away that second fraction. Here is when you have two mixed numbers. If I have 3 3/5 minus 2.5, just take the whole numbers and deal with them first. 3 minus 2 is 1. Because eventually I have to take away all of this from this. So if you break this into two parts, it might be easier to take things away. So 3 minus 2 is 1. Now bring this 3/5 down and still take away the 1/2. Get the common denominators that you need. Again, think about the fraction size. This one is big enough to take away this one. So then you have 6/10 minus 5/10, and you get your 1 1/10. Okay? The old way, again, if you wrap the whole thing up together, then you could have, if you had 5/5 plus 3/5, you would get 8/5. But you have to have, 18. 5 times 3 is 15. It's not just 1 here, it's 3. So you have to, that's what the multiplying is really helpful for. 5 times 3 is 15, plus 3 is 18. If it was 1, it'd be 5/5. But it's not. So 5/5 is equal to 1. So how can I get 3? Well, it would be 15/5 because 15 divided by 5 is 3. So all this stuff is necessary for understanding the relationship between the whole, the fraction, and then this subtrahend, because we have to take away all parts of this. So I end up with the old way, having 18/5. 2 times 2 is 4 plus 1 is 5, minus 5/2. 18/5 minus 5/2. But I still don't have a common denominator. Got to get a common denominator. And again, if 2 is the scale factor for 5, then you have to multiply 18 times 2 in order to get the increase in pieces at the same scale. If 5 is the scale factor for 2, then 5 times 5 is 25. Then you still have to do your subtraction, 36/10 minus 25/10. And you get 11/10, which you can straighten out into a mixed number there. Now here's another one. This is the new way. And again, thinking about how big is my subtrahend? How big is this thing I'm taking away? Is my whole number large enough to just take this whole thing away? Because boy, that would be easy, not gonna lie. So you take this 3, just move it down. Forget about this for a minute. 3 minus 2.5, haha, it's almost the whole thing. It's a half is left. So now bring it down 3/5 plus 1/2, and then get common denominators and put it back together. So you take your 3/5 and turn it into 6/10. Take your 1/2, make it 5/10, and you end up with 11/10 again, and turn it into 1 1/10. The only time this is going to be a problem, so watch out, is if, let's say instead of 3 3/5, you had 2 3/5. I can't use this whole number to take away 2 1/2. It's not big enough. So 2 minus 2 1/2, you can't work it that way. So you would have to use a different method. So that is a lot of notes for this lesson. So I'm only going to be able to do a few problems on the rest of this video, and then I'll do the word problems on a second. So this is in your book, and it's to generate equivalent fractions to get like units, and then we're going to subtract. We have to have like units. This one will only go to here so that we can, remember, it's like labeling, okay? So we have to have like units if we're going to be able to add and subtract fractions. So 1/2 minus 1/3, and this is the first thing that will throw people off because they're like, well, this is a 3 and that's bigger than a 2. But no, remember, this is the size of the pieces. The bigger the number here, the smaller the piece if you have the 1 on top, okay, when comparing these two. Now, we're using numbers to get our equivalent fractions. We're not using area models anymore. So how can I get a common denominator between 2 and 3? If you need to line things up and do your skip counting, please do. 3, and remember your scale factor is up here. 3 times 2 is 6, 2 times 2 is 4, times 3, 2 times 3 is 6. Now that I have my 6, and I'm getting like units numerically, change each fraction into sixths. How can I get from 2 to 6? Okay, the scale factor is times 3. Well, it's right here. 2 times 3 is 6. So 3 times 1 is 3. 1/2 is equal to 3/6. Again, remember Mrs. Edna's rule for number 1. Rule number 1 is look for the doubles. 1/2 is equal to 3/6. It's just doubled on the bottom. 2 3s make a 6. That's what it means. And then 1/3, how can you change that into sixths? 3 times 2. So times 2, there's your number. 2 times 1 is 2. 3/6 minus 2/6 equals 1/6, and that's your answer. So we're making like units numerically, and now we're subtracting, okay? So that was pretty easy because we don't have any mixed numbers yet. 7/10 minus 1/3, again, we just want to make like units, so 10 and 3, and count by the bigger number first. 10 is not a multiple of 3, so I can't use 10 as my common denominator. If I skip count by 2 10s, then I end up with 20. Also, not a multiple of 3. Okay, so my next one times 3 is going to be 30. That means I'm back to multiplying to get the common denominator for both. So this one is the scale factor for this, and this is the scale factor for this. Now look at how we're going to relate these to the numerators. I want to make 7/10 into some 30ths. So 3 was my scale factor. That means 3 is the number I multiply by 10 in order to get 30. So 3 will be the number I multiply by 7 to get 21. In the same way, I'm going to take 3 and I need to get 30ths. It would take me 10 3s to get to 30. Okay, and I know that because I know my facts. And we already determined that this is the only way to get that common denominator is to multiply by the scale factor of 10 here. So 3 times 10 is 30, so 10 times 1 is 10. And again, it has to be equivalent. 1/3 is equal to 10 30ths because there would be 3 10s for 30, so one of them is 1 out of 3. 21 minus 10, and we have our 11 30ths, and so we made like units numerically. All right, next one. This is where we are so happy that we do not have to multiply 8 times 4. You should be so thrilled. Now thinking about 8 and 4, okay, 8 times 1 is 8. But 4 times 1 is 4. How about times 2? Well, I get 8. And so look at that and use the lowest common denominator. I want to use 8. If I use 8, I don't have to change my first fraction at all. How nice for us. We don't have to have a different model. We don't have to do any work for it. Leave it alone. I just have to change my second fraction to eighths. How do I do that? What's my scale factor? If I have 3/4 and I need to multiply by something to get eighths, what is the scale factor? It's right here, 2/2. So 3 times 2 is 6. 6/8 is my equivalent fraction. 7 minus 6 is 1. And there's your answer. Okay, how about the next one? Now we have mixed numbers. These are fun. Okay, so think about this. 2 out of 5 is just a little bit under half. 3 out of 8 is just a little bit under half. What method would you want to use? We can do a couple different things. Let's start out with the classic old method, and then we'll see what we can do with our new method. Okay, so 5 times 1, or 1 could be 5/5 plus 2 would be 7/5. From that, I could take away 3/8, but I have to have a common denominator. So how much work is it going to be for you to get this common denominator? Okay, I have to have, if you line them up, you can skip count, but you might recognize that there is no other multiple that 5 will go into for 8 until we get to 2, 3, 4, 5. So times the opposite one is your scale factor. So we're going to use 40. Okay, times the opposite denominator. So if the other denominator is your scale factor, I need to get from 5 to 40 by multiplying by 8. So 8 times 7 is 56. See what I mean by using the old method? You get really big numbers. And then 5 times 3 is 15. And if I have 56 minus 15, we have 41/40. So as long as you're good at your subtraction, you can still do that if you want. Let's compare it real quick with a different method. What if I have my 1 2/5? 1 2/5 minus 3/8. And instead of using 1, I call it 8/8. Can I do that? Sure, I can call it anything. It's 1. So let's take this 1 and take away the 3/8, and that gives me 5/8. So I just need to take this away from either this or this. It's just a whole and some fifths. So I'm going to use the 1 as 8/8 and take away the 3/8. And I got 5/8. What about this part now? So put that back. So now I have 5/8 plus 2/5. And I'm kind of back where I had the eighths and fifths, and I have to have 40ths again. So it can work both ways. And again, this is my scale factor. 5 times 5 is 25. 8 times 2 is 16. And then you put those together, and then 6 and 5 makes 11. Carry that 1 over 2, 3, 4. And you end up with the 41/40 that you had before, which is equal to 1 1/40. So a couple different ways to do these. Sometimes a lot of work for both. Sometimes it'll be easier, much easier one way than another way. It's really up to you. 1 3/10 minus 1/6. Did that seem like fun to take this away, to use the new method? Why don't we start with that first? Instead of 1, what would you, it's like, I wish I had. What would you like to change it to? I'd like to change it to 6/6. Then I can take away the whole thing there in one step. See how I did that? I just took away the 1/6, and now it's all done. What about the 3/10? Okay, let's put that back now. So now I have 5/6 plus 3/10. Now here's where it can benefit you to find a common denominator that's not 60. I could multiply and get 60, and that would be okay, but I don't really want to. I want to find something lower. And if you remember, 20 is not a multiple of 6, but 30 is. Yeah, 12, 18, 24, 30. Yeah, look at that. So I can use 30ths instead. So I'm going to convert 5/6 to 30ths. So what's my scale factor for 6? It's not going to be 10. That would give you 60. So it's 1, this is the times 1. It's 2, 3, 4, 5. 5. So 6 times 5 is 30. So 5 times 5 is 25. And 10 times 3 is 30. So 3 times 3 is 9. You have to use that scale factor. These are kind of wonky, kind of crooked, but your scale factor is up here. Okay, and it's going to be different for each one, remember. Now, 25 plus 9 is 34, and then 34 thirtieths would give you 1, because it's 30 thirtieths, so that's 1, and then the 4 extra. Now, if you remember my rules for simplifying, all even numbers are divisible by 2, and I wouldn't want to leave this with both even numbers, so if you can remember to divide both parts by 2, then you would get 1 and 2/15 as your simplified and final answer. Okay, let's do another one. These are getting good. Okay, how about, I look at it and I'm like, oh, I just want to use the new method all the time. Let's try the old method again and kind of mix it up. You can do what you like, actually. You don't have to do what I'm doing. If you prefer the new method and you want to take 1 1/5 away from 2, you may certainly do that. Well, if we do 2 minus 1 and 1/5 first, you can do that. So 2 minus 1 would be 1, but then continue subtracting down the number line, which is our next strategy. So 1 minus 1/5 would give you 4/5. Then you have to put back the 1/3. Now you have to have common denominator between fifths and thirds, so let's make it 15ths. 5 times 3 is 15, so 3 times 4 is 12. And 3 times 5 is 15, and 5 times 1 is 5. Sorry, I just stopped talking there. 12 and 5 is 17/15. And you get 1 and 2/15. It also looks like it could be pretty easy for the old way. 3 times 2 is 6 plus 1 is 7. 7/3. And then if you wanted to do this, 5 times 1 is 5 plus 1 is 6. And so you can, again, get the 15ths as your common denominator and work out the subtraction that way. I'm going to go ahead and leave it this way. That's the answer. You can choose which way works best for you. Next and final one on this video, we're just going to finish out the front, and then I'll do a separate video for the back. 5 6/7 minus 2 2/3. So let's take a look at this like we did with our practice problems. If I take away the 2 right away, 5 minus 2 is 3. Now let's just take a look at the fractions separately. I still have to take away the 2/3. Okay, so I have 6/7 minus 2/3. And what I can do here is I can take my 3 and change it to accommodate my subtraction here. So I could say make it a 2, okay, and take away the 2/3 from 1 whole. You can make it an improper fraction. You can do 7 times 3 is 21, plus 6 is 27/7 minus 2/3. You're still going to have to get that common denominator. So let's make 3 a 2 and 3/3. Okay, so I'm still, let's see, I'm still, which way should I make my little caret go? There you go. This is 3. It just looks different, okay? 2 and 1 makes 3, okay? I'm going to take my 3/3 and subtract the 2/3 from that. 3/3 minus 2/3, that's a third. So now I have 2 1/3, okay? But I've been ignoring this 6/7. So I need to put it back. Still have to get a common denominator. Leave the 2, it's still going to be there. Make those common denominators. I need to get from 3 to 21, it's by a multiple of 7. 7 times 1 is 7. Need to get from 7 to 21. It's by a multiple of 3. 3 times 6, 18. And it's addition here. And I know that's going to throw a lot of kids off going from subtraction to addition. And they're probably like, oh my God. Okay. But now it's just the 2. Leave the 2 alone for now. And add up your 18 and 7. Took me a second there. Okay, 2 and 25 21st, but I still need to take this and turn it into a proper fraction. So 1 and 4 21st is our proper fraction that we need to combine with the 2. So your final answer after all that work is 3 and 4 21st. So you have options. You don't have to do it this way. You could have wrapped it up and done 35 plus 6 is 41 sevenths, and you can do it that way, but then you have to get the common denominator. You can get really big numerators, so I don't like that way for that problem. Now, here's that number line that I was talking about earlier. So draw a number line to show that your answer to G is reasonable. How do I know that 3 and 4 21st is a reasonable answer? So if I start out with 5 and 6 sevenths, let's have 6 at the top of our number line. 5, 4, 3, 2. Let's see if that works for us. We have 5 and 6 sevenths, which means it's almost all the way to 6. 6 out of 7 pieces is roughly here. I have to take away 2 and 2/3. Now watch me hop. Take away one whole so that you end up a little bit below. Take away another whole so that you end up a little bit below the whole, depending on where you start. So that's -2. Okay. But I also have to still take away 2/3 more. So let's break this into 3 pieces here. I have to take away 2/3. So if this is 1/3 and this is 1/3, I end up somewhere a little bit more than 3. Look at that. That's a little bit more than 3. 3 and 4 21st. If 3 was broken into 21 pieces, that'd be roughly 4 of them. So we're kind of approximating where we would be on the number line. And remember, with the subtraction right here, we're taking all of this away from this. So you have to keep moving down the number line. And you guys will say, but what about over here? I'm adding. Well, you're only adding because we did it numerically by taking the whole thing away from the whole. And then we had to put back the 6 sevenths. So that doesn't necessarily connect with the number line. The number line is just that continuous subtraction. The number line only is taking 5 and 6 sevenths and modeling -2 and 2/3. Okay, so yes, it's a reasonable answer. Yes, it's reasonable. I know this is super hard and confusing, but hang in there because as you get more practice, you'll feel a lot better about it. So if it's helpful, and even if it's not, click subscribe, come back again. A lot of the other videos aren't quite this hard, but I'll do the word problems on the next video. So back side of this page coming up next. Bye for now.